All right. Hi everyone. Hello. So no quiz today, but there will be one on Monday. So we'll I don't think it makes sense to do them in like the first 2 weeks, but after today, hopefully we'll have had enough that there would be kind of real things to ask in the quizzes. I'm not changing the format, so it's still going to be the annoying Quirkus one, unless I figure out something that's better. And that means that realistically, I can't really police like who's in the class, who's not. That said, I hope it's going to be kind of a motivation to keep up with the class because, might as well because the midterm is coming up. And I will be putting kind of substantive stuff there. At the same time, it's going to be the same format as last time, which means that like it's not going to be difficult to pass the quiz, but it will give you maybe an indication of where you are. So okay, so I'll just quickly review the slide with the rules, and then we'll go into new stuff. Right, so you have to declare the type of the variable, right? So for example, int is a type, char star is a type, and so on. Int star specifically means a value that holds an address of an integer. That's different from saying star PA without the int, which means go to address PA and get the value there. Ampersand is the other way. Ampersand, so I don't know, by the way, if everyone knows, so like the and sign is called an ampersand. So ampersand A means get me the address where you decided to store the variable A. And that matches up. So the variable PA, so this guy is able to store address of A, and that's because it's of type int star, of type address of integer, or sometimes we say pointer to integer. So pointer and address, those are the same thing. So, okay. So we will skip functions for, well, let me review functions. We're not going to be using them in the first part of the lecture, but nevertheless. So when you're saying something like f(43), what happens is the value of this, whether this is a variable or whether this is an expression, or in this case, it's a literal, right? So you inputted 43 into the program, that means it's a literal. It doesn't matter whether it's a variable or a literal, whatever's there just gets copied to whatever's here, right? So 43 gets copied into A. So that means that the variable A and the number 43, they happen to be equal, but that's for now. So if you say A equals 42, well, A now stores the number 42. 43 is, of course, still 43. That works. This is kind of a common confusion, I think, and I'll stop and ask people if they get it. But this works exactly the same, right? So you're sending the value address of A. So address of A is an expression in the same way that something like 5 plus 7 would be an expression, right? So you would compute 5 plus 7, that's 12. You would send it over there. In the same way here, you're saying, okay, I'm sending the value of the expression address of A, which happens to be the address where A is stored, and I'm sending it to the variable PA. So when you say I want the variable PA to be something different, okay, now the variable PA is something different that does not affect this in any way. So the only subtlety is it can be that the mechanism is exactly the same. All the rules are exactly the same, except the function does have an effect. And the reason in this example there is an effect is that you're sending the value that happens to be the address of A to F, and then the job of the function F is to actually go in the memory table to the address that you gave it and change the value at that address. Right? So it's not that the mechanism is different. It's that you are saying, you know, like, here's a number. This number happens to be an address. Go to that address and do something. For that reason, that can have an effect. Yes?
What if we give void F in PA and then we change star PA?
Sorry, I can't really understand code when spoken. So
Okay, no, we gave F of in PA without the star in the parameters.
F of ampersand PA. So the types have to match.
I see.
Right? So that would just be a compiler error. So you cannot send an integer when what you're expecting is an address of integer. So C protects you from this kind of situation. In general, however, you can force it to go. So what you're asking about, I think, is what if you do this?
Yeah.
And then if it did compile, what would happen is that, which you can force it to, is the number 45, which is the value of A, would get sent to PA. And then what this would mean is go to address 45 in the memory table and modify the value at address 45. Now, this would not compile. If it did, this would probably crash because probably you're not allowed to access address 45. The program is allowed to access like a specific range of addresses. Yes?
But then instead of saying that PA is 8 star, you could just say
again, type mismatch, it would not compile, right? So this value is of type address of integer because it's an address of 8, and then this matches with this type. So like most of the things you would try, like if the types match, it's either because you intended for them to, or it's a really weird coincidence, right? So most of the things that you try that are not exactly this would just not compile because the types would not match. And there's no kind of there are kind of some exceptions where you can kind of slip by the restrictions, but in general, it just would not compile. So one way in which I did kind of slide by is here, where I said PA equals 0. So that you're allowed to do specifically with 0 with no warning. If you try PA equals 12, you would get a warning because 12 is an integer, PA is an address of integer. So if you don't specifically say, yes, I definitely mean 12 to be an address, you would say it like this. So you would cast it to n star. You would never actually want to do it because it's a made up address that's fake, and accessing it would probably crash the program anyway. So that would give a warning. So 0 is special because 0 is always 0, regardless of whether it's an integer or an address. So that you can do without a warning usually. Again, if you try to access address 0, that would crash because it's a fake address. But in fact, it's like the common fake address. So that would specifically say, not only are you trying to access an address that's not valid, it happens to be a 0. So that's usually a special cut there. But that would be when you run the program, not when you compile it. So we'll get to that. So, okay. So does this make any other questions about this? So does this make sense? So again, like so there's two ways to go about those kinds of things. So one is you just remember a bunch of templates and you say, okay, like if I want to if I want to modify an integer, what I got to do is, and I'll do it in a second, is I got to send it a pointer to the function and then I can modify it. If not, then not. And I think that's, in a way, if you're used to writing in C, you implicitly memorize those kinds of templates for what do you do if you want to modify the value? What do you do if you don't want to modify the value? In which case does it get modified? In which case does it not get modified? At the same time, I think it's important to, in the beginning, but also kind of as you're programming, because sometimes you get it wrong and then you're trying to debug it, to recognize that there is like one very simple rule about how values are passed to functions, which is they're always getting copied. And just the semantics, like what does it mean that you're doing an ampersand? What does it mean that you're doing a star? That's kind of all that you need to know. You can predict the behavior of anything from first principles if you just trace out the rules. And I think when you first learn about it, and I think that's most of you now, it looks like big and confusing. I think it could help if you think about it as, well, it is big and confusing, but at the same time, it's like 5 rules and tools. So just go through them. We listed them out last time and try to trace out some code. There will be exercises with that as well, but you can make your own. So, okay. So let me do some examples. So if I want to say that I want to change a variable, so let's say I have an integer a and I want to change it. And I want to do it using something like change a. So it has to be that I'm communicating what the address of a is to the function whose job it is to change a, because it doesn't matter. If I'm doing this, whatever I do, all I'm telling it is I have this secret variable whose value is 42, please change it. Can't, because there's lots of variables. Some of the values of some of them is 42. If you're just giving it the information 42, that's not enough information to be able to change any particular variable. So it has to be address of. So if what you're doing is you're sending the address of a to change a, that means that the parameter of change a must be of type int star. And those match up, right? So this is address of a, and this gets sent to PA, which is of type int star, because address of a is the address of an integer. And then in here, you would say PA is 43. And that will have changed it. So this is as opposed to not changing it. There are, of course, many ways to not change a, but the usual thing that you might try is you might say, well, a is equal to 43 over here. That does not work, so that changes the value of the local a. let's make it 44 so that there could be a potential there. And it's important to understand that, like, it doesn't matter what's in don't change A, right? This is the same as don't change A 43. Right? It's like literally the same. In both cases, you're just sending the value 43 to the function don't change A. That means there's absolutely no way that don't change A would know how to change the value of anything. Because all the information you're giving it is the number 43. Yeah.
So in a sense, it's like when you pass in just a variable A, you kind of lose some information. Whereas if you pass in its pointer, you can access its pointer and its value. You see what I'm saying?
Yes. I think that's fair. I mean, in a way, you're still passing kind of like one value. It just happens that when you're passing the address, well, the address is not just like not important in itself, but you might also go to that address to get something.
So you're able to like overwrite, whereas
but and I think that's one way of I think kind of thinking about it as like you're passing both. It's not exactly right in the sense that like you're passing like 40 St. George Street. The fact that you can actually go to the address 40 St. George Street doesn't change the fact that 40 St. George Street is just a bunch of words in some sense. All right, so that's integers. And of course, there can be variations here, right? So this, for example, can be called something that's not A, but I think at this point, like, of course, anyone would say that if you change this A to actually be X, that's not going to help, right? And this is actually 44. Right. Yes.
This function you just wrote twice. That's like.
Yeah, I'd have to. Yeah.
But like that function is different than the one in the slides because in the one in the slides, the argument int A is a pointer, right?
Yes.
So when you try and set it, the pointer to 0, you're going to get a segfault.
No, that's not a segfault, that's actually valid.
This is valid.
Yes. So star PA equals 0 might be a problem, but which in this case it wouldn't be either. But here you're saying PA equals 0, that means that you're saying set the value of PA, which used to be an address, to something new, to 0, that's fine. So what you're thinking about, we'll get to, is if you're sending something that's not a valid address and you try to change that, that's a problem. So if PA had already been 0 and you said star PA, that would be a problem.
The other line after this.
Yeah, so if you say like P star PA, so like star PA anything, that's a problem. Yeah. Yeah, but setting a pointer to 0 is actually like an extremely usual thing. So it's accessing a 0 pointer that's the problem. All right, so we'll get to that. So, okay. Other questions? All right. So all of those things no more. So there is for now, and in fact in C, unlike in Python, it's not super usual to have global variables at all. So here we're just for now talking about local variables. For completeness, we'll talk about global variables in C. Just like in Python, there is a way to set a global variable inside the function, and that also would communicate information from the function to outside of the function. So that's possible, we're just not doing it now. But if you're just communicating with the function via parameters, then that's basically the options, and that is the way to change a value. So the usual example people do, and I'll do it now, is let's say that you want to swap two variables. And you want to say swap. So again, there is absolutely no way that you can swap x and y this way if swap is a function. But if you give the function the address of x and the address of y, then that is fine, right? Because in principle, the function can say, well, take the value of x and put it where y used to be, take the value of y and put it where x used to be. So you've done it. In fact, most of you have done this. So that would be like this. So p underscore, that's just what I use in order to indicate that when I use this variable, it's probably some kind of address. Of course, it's all just a name. You can name it whatever. Usually, I prefer to not name this kind of thing and this kind of thing the same. So I prefer not to say x here, even though technically I could. C doesn't care what you name things, right? And that's just because I want to maintain the distinction between x and px. In the future, you'll see that this kind of plan does not always work out, because sometimes it's easier to omit the p underscore, just because there's multiple considerations, but for now this works. So here, so C does not have the multiple assignment thing. So we'll have to actually have a temporary variable. So we'll say, okay, so the temporary variable is star px. So that means I just gave you the address of x, go to that address, get me the value, and put that value in temp. So here, notice that temp is just an int because the value at the address px is an int. On this side, we have a star because we're saying go to address px, get me the value there. And now that you've saved the value of px, you can overwrite the value at address px with the value from address py, and you can set star py back to temp. So that's the usual thing that we do if we can't have multiple assignments. So, okay, how many people are good with this example? So I feel like not everyone. So let's try something. So here's a picture. So I am in a BA 2028, and Professor Hooper is, I don't know, I think 2030. So something like that. So this would be Michael, and this would be Morgan. Okay, and let's say that you wanted for us to switch offices. So I go to Morgan's office and Morgan goes to mine. Right? So how do we go? So how do we go about that? Well, the idea would be, so swap, this is like the fake swap. So this is like office number 1. And this is like office number 2. So I'll write it kind of like in Python, right? So the idea here would be put the person in office number 1 in the hallway, right? And then put the person in office number 2, in office number 1. And then now that like our offices are pretty small, so you kind of have to do it that way. And now you can put the person in the hallway into office number 2 because that's now not occupied. Right? So inside the main, what we would do is office swap, and then we would say like address of Michael and address of Morgan. Right? So this kind of function office swap, it gets my office, it gets Morgan's office, and now it can order people about by going to office number 1, telling me, go into the hallway, whatever. Right? So that's exactly what's going on. Does this example make sense on itself to everyone? Does it not make sense to someone? Okay, nobody's complaining. So, okay. So what we're doing here is instead of people in offices, we have variables and addresses of variables. So addresses in the memory table. The memory table is very much like the Bayesian hallway, right? So it has, you know, cell numbers instead of office numbers. In fact, they sometimes skip because the office, like if the office is too big, you skip some numbers. So that works exactly like the memory table in that sense. So like in order to store a big office, you need several numbers. And here, so we're sending the address of the integer x, the address of the integer y, and then here we're saying put the value of x into a temporary value, into a temporary storage, so that you can overwrite the value at the address px. Okay. All right. So this is this. So that's integers. So now, if we want to do the same kind of thing with blocks of memory, it's like this. So if you do this and you define array to be whatever, 5, 6, 7, you can say set array 0 array, and that changes array 0. Right? And the reason is when you're saying array here, what you're really doing is you're sending the address where the 5 lives. So saying array at 0 is 44 is, yes, going to where the 5 lives, this 5, and changing it. So the rules are still the same. You're copying the value from over here to over here. It's just that what you're copying is array, which always gets converted to the address of the first element. And as you remember, that's the same as. Okay, yes.
How come for that function, it says you need a int star, but you give it a regular int?
It's not a regular int, it's an array, right? So that's this thing. So if you're defining the array, it's so you're putting the square brackets here, and that indicates that it's an array. And on the right-hand side, you also see that we initialized it with 5, 6, 7, not just one number.
Does it behave the same way as the int star?
So it does not exactly behave the same way as the int star. If you look at the discussion from last time of size off, That is one difference. But what happens is an array of ints, anytime you use it outside of very specific context, just gets converted to the address of the first element. Right? Make sense? So, all right. So that's like that. And again, kind of one way to think about it is those are the rules. You are sending the address of the first element. And that's why if you go and to that address and change the value, well, the value over here changes because there's just the 1.5. A shortcut is to think of if you're passing something that's like an array to a C function, then if you modify the contents, that's going to have an effect outside the function. So in the same way as when we think about passing Python lists to a function, if you go and modify the contents of the Python list, that would change the contents outside the function as well. As you remember from the exam, there are complications, right? So when it's lists of lists, things get complicated. Things will get complicated in C as well. I promise you, you will not be bored. But that's the shorthand, right? So you pass something like an array, you go and modify its contents. Yes, that changes the value. You pass just a value that's an integer. You can't just change it inside the function. However, if you pass the address of the integer, then you can go to that address and change it. So the last thing is, what if you do this? So that changes the local variable r to 0. And that's exactly like Python, right? So if you remember, you go and change the contents of the list, that might matter, but you change what the list itself is, that doesn't matter outside the function. Why does this make sense here? Well, it's because r is a local variable like any other local variable. You set the value of that local variable to something new, that doesn't matter. So what might matter if that variable happened to be, again, like BA 2028, my address, if you go to my address and change something in my office, well, that might matter to me as well, not just to you. Right? So for that reason, that can change things, that cannot. Because this is just saying I had BA 2028 written down like somewhere, and then I went to my note that said BA 2028 and changed just my note that said BA 2028. That changes the note, doesn't change anything else. Yes?
How do you take the second or third variable for the array?
So you can just say like array 2. So that can be anything. Yeah.
If you pass the address of the array name, which means pointer to pointer, what kind of error is that going
So that's kind of a special case that I don't necessarily want to get into. But it so happens that address of our array is the same as array, and that's specific to arrays. So because an array is just an array of integers, it's just a bunch of integers in the memory table. You have to kind of decide, okay, like what does it mean? So, and we already know that array itself gets converted to the address of the first element. What else would you say address of array is but the address of the first element? There's nothing else. So for that reason, yeah, like you say that it's actually the same. Yeah.
Does that mean if you pass ARR as an address into your function above, and then you try to do address of ARR,
Again, like they're literally the same.
now it's not an address. Now it's not an array.
Oh, it's not an array anyways. So like anytime you use it, it gets converted to the address of the first element. So I think you might be asking, like, what if you do something like this? Okay, yeah, okay, in that case, what I answered before is, is what it is. All right, okay, so let's not get too into the weeds here. So that's the review. So, okay. So I want to talk a little bit about strings. So C does not have strings is the first thing to say. So what C has is a bunch of characters that are stored in a sequence. The distinction might be a little bit thin, but basically it's about like, that's all there is. So characters and then a null that indicates that the string is over. There is not like a special thing beyond that that's a string. And there are actually two things that you see that are like strings in C that are in Python, sorry, that are slightly different. So you can have an array of cars. So S1 is an array of cars. And doing it this way, this is just literally shorthand for initializing an array of 4 elements, 4 because there is a null there as well, where the elements are A, B, C, and then the null. So this is, it's a little bit misleading that way because like this is like literally this. It's not anything else. This is slightly different. So this is kind of analogous to Python. So this is saying put the string ABC somewhere in memory in the same way that when we're declaring an actual string in Python, we put the right-hand side somewhere in memory and then put the address of the A into S2. So the practical difference here is that this is a local variable. So if you communicate this address to somewhere outside the function, the address would not be valid. This guy will actually persist because this guy is not actually just shorthand for this. So we'll see that is an important difference. I mean, meaning like your code will crash if you do the wrong thing, and sometimes you want one and sometimes you want the other. But this is in a way just a preview for this. And the reason we're doing it kind of all at once is because, yeah, like you write hello world and that already involves this kind of thing. And it already gives you a warning if you do this, which I'll explain in a second. So we kind of have to front load the material a little bit and then kind of chew on it for a couple of weeks. So hopefully it'll be fine. So actually, the literal ABC is not of type char star. That's why for most of you, if you type in the code that used to type in the first several lessons for simplicity, you'll get a warning. So that's because ABC in quotes is actually of type const char star, not of type char star. So usually the compiler will tell you, actually, it's like const char star, not char star, but it's a warning, it's fine. So here's what const means. Const means that if you go and try to change the contents, you're not allowed to. So if you define things like this, so if you say S2 is XYZ, and then you go and try to say S2 at 0 equals Y, that will just not compile. And that's what const means, is you're not supposed to change the value. You can do this. So what this does, which is what we've done so far, is to say, well, what's the right-hand side really is supposed to be constant, but we ignore it, and we just say S1 is char star. And then I can go and say S1 at 0 equals X. That will compile. It might very well crash if you actually run the code later on. Right? And that's because just like Python strings, C string literals are not supposed to be modified. It's just that unlike with Python, with C, you can just say, you know, like my dude, it's fine, it's a car star. I promise I won't mess it up, but yeah, like if during the program run, you try to access it, it might work, it might not work. That's the other problem with C, is that you will not necessarily always know ahead of time if your program will not crash sometime in the future. Sometimes things work out, even though they're not guaranteed to work out. So sometimes you can try to modify the string and it will actually work. Sometimes it will crash. So that's kind of, so const car star is like you encounter it all the time, because anytime you type in a string into C, that's actually a const car star, which if you try to modify the contents, it might or might not crash. So the more kind of easy example, which we will not really be using so much, is just the usual kind of constant const car. So what that will do is it will just stop you from modifying the variable that you've declared. So if you say like constant a equals 42, that's fine, and you can use a, but you cannot reassign 43 to a later on in the program. You try to compile it, that will be an error right away. Same with car without a star. So it's just like a character C, and it starts out as X, and you're not allowed to modify it. So what you saw with const car star is that you're not allowed to modify the contents of the string. That's different from, are you allowed to actually change the value of str? So what you can do is you can have a car star const. And what that means is that you're not allowed to change str, but you are allowed to change str at 0. Right? So in a way, car star const is the equivalent of something like constant, right? So constant says you're not allowed to change the value of a. Car star const, sorry, means you're not allowed to modify the value of str. But it doesn't say anything about, like, if str, I happen to interpret it as an address and go to that address and change it, that's fine. Okay. So you can have both. So you can have const car star const, and that stops you from modifying both the value and the value at the address. Yes.
So if you do car str brackets making an array,
yeah,
then does that mean you can modify?
You can. Yes, you can.
The value at the address, right?
Yes. Yeah. However, you cannot. So there's just no syntax for changing an array, right? Yeah. So there's no syntax. Like if you say, I can just write. So yeah, so this is like more details than I want to do right now. But so if you say like whatever, well, we'll do car. So this is fine. This will not compile. And that's just because you can, once the array is set, you cannot change what S is. That's already set. So, all right. So that's like that. So what's the point of all this? The idea is kind of like you're trying to stop yourself from shooting yourself in the foot later on. So if you know that something is never supposed to be modified, like you're defining whatever the constant pi or something, you don't want to, like by accident, try to change pi later on in the program. It would make sense to just say, okay, it's a const. If I ever try to change it, just don't let me even compile it, right? Because it's clearly an error. So that's kind of the point. So the other question is, why are string literals constant in the first place? Like, wouldn't it be nice to be able to modify them? And the answer is arguably yes. There are several reasons. So one is kind of more efficiency, in terms of this duplicate storage. So if you define XYZ in several places in the program, just like in Python, sometimes it reuses the same memory address for several variables because they happen to be equal and they're immutable. So in the same way, in C, the choice was made that in part because of that, like I want to try to be efficient. If the user happens to have inputted several string literals that are the same in different parts of the program, I just want to store them the once. The other thing is cost efficiency, and I put in kind of like really old hardware to make the point, but it applies now as well. So what you have on the left there is a punch card, right? So up until like actually I think like probably like in the 2000s, there were still like computers and whatever, like the Social Security Administration famously has like really old systems that use like really old computers. So that is how input and sometimes memory could also be set up, is you'd have a cardboard card and you would punch holes, the specific patterns of holes in it, and that would be how you would store data, right? And obviously, once you've punched a hole, that's that. You can't go back. Well, I suppose you could like paste something on top of it, but the point is this is kind of write only. Once you've done it, you can't undo it. On the other hand, you have, so this is a picture of a magnetic tape that was also used in kind of for storage with the computer, right? And the idea is you like the tape. I don't know how many people have seen a tape, maybe not many, I don't know. So, well, you've all seen them now. It looks like this. So inside there is a roll of tape, and the tape rolls, and a magnetic head can record magnetic patterns on the tape, and that is ordinarily writable. I have seen a tape that's write only as well. So you could buy it and you could play your music, whatever. You couldn't overwrite it. I think that might have been cheaper, or I don't know why, but like there had been tapes like that. So anyway, the point is, if you are operating under those kinds of constraints, well, you might like to say, well, I probably don't want to change the string, so I'll write it to the cheap memory that's write only. And I'll save the rewritable magnetic tape for the important stuff that I might actually need to modify. On modern, so that's like basically the reason. On modern hardware, you can still have that, right? So you can have really expensive fast memory that a microchip uses, and then you could have like pre-written stuff that you don't need to modify, that's cheaper to make. So that's still possible. So that's kind of the reason. So we'll finish with a quote. So this is from Bjorn Stroustrup, the inventor of C++. We're not doing C++ there, so that's like a famous quote. So C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. So you should not appreciate the joke if you don't know C++. So Python is not really equivalent. Python is more like you just get to use a toy gun. And like one of the ways to shoot yourself in the foot is whatever, mess up the pointers, which Python just doesn't have. All right, I'll see you Monday. Thank you.